some of this is review, okay, and I wanted to put this into like kind of a formal thing for you to look at, right? So obviously today, not obviously, but today we're going to try and identify the varying forms of a parabola, right? So there's 3 different forms. I know in the 2Ps we looked at 2 of the 3, didn't look at the 3rd. And then we want to be able to read the vertex from vertex form, right, which is one of the forms. And then the success criteria of being able to read the vertex off is going to be able to navigate this process, which is like called completing the square, which I don't know if anybody's done. It's a 2D thing. It's a 3U thing. So as long like that's what today's going to concentrate on, and then identifying key features from vertex form. Okay. So you should have come across the 3 forms of a parabola. Each of them provides us with different information. For today and the next few lessons, we will concentrate on the information that can be obtained from one of the forms specifically. That's vertex form. Okay. So the next little bit, we're going to concentrate on answering questions about the vertex. Right? And how we can translate the vertex into like a word problem context, right? And what it means. So this first one, does anybody know what this one's called? It's probably the most common form, I would say, that you would see. It's just a trinomial, right? It's 3 terms there. That's what this one's called, standard form. Right? And there's 3 things I can tell from this, right? 2 of which are come from the A value. So, is there a reflection? Is the parabola opening up or down? I guess is basically what I mean, right? So reflections, right? Is a negative, right? Right? And then you can also see, based on if we look at the A value, is there a stretch or compression? Right? And then the last one is what's known as, does anybody know what the last piece of information we could find from this is? What happens if I plug in x equals 0 into there? So if you remember that if I plotted this graph, x equals 0 is this here. So if I plug in x equals 0, it's going to tell me where the graph crosses the y-axis, right? So then if I plug in 0 in for x, these 2 terms are going to disappear. And all I'm going to get left with is the c value. So the c value is the y-intercept. So I can see where the graph crosses the y-axis based on the c value. Okay?
So reflections is like the a value, stretch or compression is the a value as well, and then y-intercept is c.
Mm-hmm. For standard form. Okay, that's good. And you're going to see a commonality. Like the A value is the A value as we go through all these questions. It doesn't really change, right? So you're going to see that pop up a few times. You can always kind of tell what's there, right? So the next one, I missed one little thing typing this out. I just caught it. There has to be a squared on there. Right. We spent some time working with this now, right, though? These allow us to read off the transformations, right, for a parabola. But this has a specific name. Do you know what this one's called? It'd be vertex form. Okay. So if something's called vertex form, right, I could probably, well, before I get to that part, why don't we say, like, I still see an A value, so I can read off the same information, right? I can tell if there's reflections. And I can tell about stretches and compressions. Now, probably the most important piece of information from vertex form, and the reason why we write it in vertex form, is so we can see transformations that have occurred to the original parabola, but also something else, and it's in the name. So if it's called vertex form, we can find information about the vertex of the parabola.
Like the how to plot.
So there's the vertex is actually like visually you can see it, based when you write it in vertex form, which is the whole point of what we're trying to do today, is to be able to switch between forms so that I can get the vertex to just spit itself out in vertex form, right? So I can read off the vertex, right? And that's going to be as like it's a point, and it's going to, so points have x's and y's, right? But they're going to be like, I can read it visually off as being H and Q.
So H and Q are the
H and Q are the vertex. Q is the Y piece, right? And I'll like code it. So Q is like, Y is always kind of in blue. I'll try and maintain that as we do the course. And X is kind of the red piece, right? So you can see how the two are going to line up. So you can read the vertex off, right? And again, what's the vertex? Do we know what the vertex is?
highest point.
Highest or lowest point, right? Depends. So it's a maximum or a minimum depending on if the parabola is opening up or down, right? So if I had this, I'll draw two different parabolas. That would be a maximum, right? And this would be a minimum. Okay, those are both, we'll call them vertices, right? Vertex. Okay, the red one has a minimum because you can't go below a certain value, and the black one has a maximum because you can't go above a certain value. Right? So the minimum and maximums respectively. Right? Do we have any questions so far? We're gonna spend a lot, so that's important. This one here, number 2, is important. So we're gonna spend a lot of our time today looking at that. The last one is also very important because it allows us to answer questions, but a different kind of question, which we will concentrate on later. Right? It won't be on the next unit test. It'll probably be the concentration of the second unit test. Right? So this one is what's called factored form. And I think mostly everybody should have had some experience factoring trinomials of some sort, like common factoring or such something. That word factor should not be new to anybody in this room, right? And again, we can see, got the A value, right? So I can see, again, reflections, stretches, compressions. And then there's one other thing I can tell. And this says there's 4 different words that mean the same thing with this. So when we did that, and anytime you've written things in factored form, what are you trying to, you can write something down based on it. You can read it off. Much like I could read the vertex from vertex form, I can read something off of factored form. They were called, there's 4 words that will mean the same thing, and sometimes I use them interchangeably, so I'm going to give them to you all. We can have X-Intercepts, zeros, roots, solutions. Okay, all 4 of those are interchangeable. They all mean the same thing. They basically, like, you can tell what the X-intercept is, right? Like, if I had this parabola and I was opening down or something, right? the x-intercepts would be where the graph crosses the x-axis. So it would be here and here. They would be read off as being S and T. So because they're both x's. This could be S, and this one could be T, right? They're just numbers. So they're where the roots are, the x-intercepts. You can read them off. That's why we write it in factored form, right? And there's all these different processes that we've done to deal with different kinds of trinomials to get it to look like factored form. Okay, so that we can read off. And we'll do that later. For today, we're just concentrating on number 2, vertex form. Okay, do we have any questions? Okay, so we'll be concentrating on vertex form, right? Some experience with transformations. Okay, so we'll be concentrating on vertex form, right? And vertex form should look very similar, or very familiar, rather, with regards to when we were moving and we were doing all the transformations, right? So that's the second blank, and then the thing we're most interested in is the vertex, right? So we did a little bit of this on Friday, Thursday, whatever day it was, okay? Just so we kind of rushed it in, and it's kind of important. So we're just going to identify key features with this, right? So here's a parabola, a random one I drew, right? And I want to answer like all these questions, right? So direction of opening, is it opening up or down? Up. And I think the grid got flipped somehow. I don't know how the grid got flipped.
Did you say up or positive? Did I say positive? Is it the two changes?
The A value is positive, but then that indicates the parabola is opening up. So they're kind of related. They are related, but I prefer up, right? Then the vertex. Somehow this grid got flipped. I don't know how it happened. But anyway, the vertex is right here. We could renumber this to be negative and positive over here if you want. Okay. So we can say it's at -1 and +2. Right? So the vertex is actually a point, right? -1 and 2. Okay, and then the optimal value, is there a maximum or a minimum? There's a minimum, right? Because it can't have any lower, so you get the circle, it's a minimum. It's a minimum at x equals -1, right? And then the axis of symmetry is where the parabola gets split in half, right? So the axis of symmetry actually takes on, remember we talked about what this was. That's a vertical line when all the x values take on one particular value, right? It's a vertical line. The y-intercept will be at 0, 4, right? That's this point here where it crosses the y-axis, right? And then the x-intercepts, do we have any x-intercepts? None, right? It doesn't cross the graph, so none. Okay. So the two pieces of information we're kind of interested in here, you always kind of want to ask yourself is my parabola opening up or down? So am I going to get a maximum or a minimum, right? So up, down, right? And then as a result, is it a max or a min? And then what the actual value is. So in that case, we're going to say the vertex, right? Those are the two, like, if we can grasp this notion of where the vertex is, if there's a maximum or minimum, that's one concept. The second concept is how do we get there? That's completing the square. And the third concept is going to be coming up with the equation from words, like word problems. So we've got like 3 concepts left, right? The first one's kind of imperative to understand what we're trying to do. So we just got to understand that, like, I'm interested in if the parabola is opening up or down, right? And whether or not I'm going to have a maximum or minimum value as a result. Right? The second process is how do we get there? Okay, so let's look at the first one. Direction of opening, up or down for the first one? Up, because the A value is positive, right? So it's going to open up, and then as a result, is there a maximum or minimum? Minimum, right? Because if it's opening up, I have a low point, so there's a minimum, right? Now here's where the catchy piece is, right? Do you remember where we said? Do you remember in transformations, if I saw brackets, what it meant? It behaved opposite. So here's the tricky piece, right? Is that parabola going to move right or left? Yes, right. So it has to be opposite, right? So if I move it to the right, it moves into the positive values, right? So then the vertex actually just takes on this value, right? The x value of the vertex is going to be 4, and the y value is what it is on the end, right? It's just going to be 3. Oh boy, what's going on? Okay. Okay. So then the vertex is going to be 4, 3. So I could write a therefore statement about the vertex saying, therefore the maximum is 3 when x equals 4, right? You could say, okay, and then you could throw words on top of that. It'd be like, the maximum height reached by the ball is 3 meters when time is 4 seconds or something, right? Just start throwing words on it, right? And interpreting the words from the question, right? But we'll just do the next one. Okay. I see a negative out front, which means it's going to open down, right? If a parabola is opening down, that must mean I'm having a vertex, or a maximum, sorry. And then this one, if I knew I had to move my parabola, it's opposite. I see a positive sign there, which means I'm going to move it left, so I better be in the left half of my graph, right? So I'm going to move it left 3, so I know that my vertex is going to be negative 3, positive 10. Does anybody have an issue with that? Okay. You can always just treat it, it's always opposite. So if you're just looking at this visually, you're like, okay, this one here, negative 4, I have to move it to the right 4 so that the value is going to now become positive 4, right? This one here, I see plus 3, means I got to move it left. It has to be minus 3 in my vertex. Okay. And then you could say, okay, therefore, oh, you guys didn't correct me. It's a minimum. The minimum is 3 when the x equals 4. And then therefore the max is 10 when x equals negative 3. Okay? This was reading stuff off now, right? There's like you should have some. The first page kind of like, here's your y-intercepts from standard form and your direction of opening and all that stuff, and then vertex form lets you read off vertex, and factored form lets you read off information about x-intercepts, right? Those are the big concepts, right? Which is spend a ton of time in 2D discussing those concepts. Like half the course is spent around quadratics and the stuff we're doing here, right? It's not easy. So, completing the square. Okay. Does everybody understand why we need things in vertex form, right? Want to be able to answer questions about the maximums and the minimums, right? That's why we're doing this. So completing the square allows us to do that. It's to get it to a stage where I can answer questions about the maximum and minimum, right? So basically, I'm going to be provided a word problem or something, and when I write the equation, it's going to spit it out in standard form, right? So I'm going to get this thing that looks like this, right? Like the very first question here, y equals ax squared plus bx plus c. I'm going to get something like that, and then I'm going to do this process of completing the square on it to make it look like vertex form so that I could read the vertex off. Okay? That's the whole point. It's not an easy process, but I promise if you do 10 of them, you'll never mess it up. It just goes on autopilot. It's just 100% about how many of them you do. Right? The hard part is not completing the square, it's coming up with the equations from word problems. Okay? So let's not let the completing the square piece be the problem. Okay? So we're going to switch between standard form and vertex. All right? That's going to let us answer questions. Okay? Any questions? Okay, so I'm going to do this question. We can watch it if you want. You can just watch me do it. You don't have to copy it down. I'll post the solution to the video for the lesson. But I've already done this question, right? So if you wanted to scan that QR, it'll do the lesson. Like there's a separate video for it already. It's there if you just want to watch that piece, right? So here's how this works, okay? There's this like kind of magic thing that happens, and like if you can identify this right from the beginning, I don't need to show you anything, right? It's just like you're just gonna do this every single time and just write. You can do this in 3 lines. Really, it's not that long. So there's this like kind of magic number that happens, right? I always label it Z, right? And Z is always equal to the B value from the standard form. So remember, standard form is y equals ax squared plus bx plus c. So it's always this number here, right? Is b is b. Okay. So it's always b divided by 2 squared. Get this magic number, right? Okay. And then you can just do the math on it. So you're going to go, okay, well, z is equal to 5 divided by 2. Right? And then z is going to be equal to 2.5 squared, which is going to be 6.25 if I'm not mistaken. Okay? So z is like, this is your magic number here, right? And actually, well, it's not, yeah, you'll see in a minute. It's like, it's not actually the magic number, but there's a magic number that creates that number, obviously. Okay? So the way this works now is, this is always your kind of like first step, go to, right? You're going to go, okay, I'm going to collect or find what the z value is, right? And then the second step is I'm going to introduce these kind of square brackets, right? And I'm going to take this term here and I'm just completely going to forget about it till the very end of the question. Just going to not even think about it for the rest of the question. I'm just going to throw it away, right? And what's going to happen is on the inside of the brackets, square brackets, I'm going to write x squared plus 5x. And then I'm going to take my z value, so plus z minus z, close the square brackets, and then leave the plus 6 on there. So you're going to see that plus 6 carry all the way down to the very end. Okay?
Why do you
So it's a good question. So you add z and take away z. Have I changed the question? Because if I add and subtracted it, they cancel out to be 0. I haven't changed anything. But I've manipulated something. That's the important part. Okay. So the next part is just throw the z value in. Okay. So we're going to get x squared plus 5x plus 6.25 minus 6.25. And you're going to have that plus 6 floating about on the end too. Okay?
So basically you said it was positive and you just like subtracted it to get rid of it. Basically.
You'll see why in a sec. Okay, so this is like, as long as everybody's okay with this, it's a little bit weird, and it's like, why? It doesn't make sense. It doesn't make sense. Like, and I don't expect it to make sense where we're at right now, right? But what happens is interesting now. Okay, and I maybe should have picked the question. Maybe the bottom one will work a little bit better. We'll see. But something interesting happens with the first 3 terms now. So if I do this, and you don't have to do this. This is me just stepping you through this. At some point, you will not do this. You will just recognize this and just write it in 3 lines. But I'm just showing you the work. Okay. There's something interesting that happens here. Here's a trinomial, right? You know, one term, 2 terms, 3 terms. Now, if I were to factor that, right? Then again, this is a little bit of review. We'll do more factoring later. You can get away with this without needing factoring, which is why we're doing it in this order, right? So if I were to factor this, I'd need 2 numbers to multiply to 6.5 and add to 5, right? You remember this? Let's add to the middle term and multiply to the last man, right? So we got to find the 2 numbers that satisfy those conditions. So you can sit here, and this one's a little bit trickier because you have a decimal value. But this is where this magic number that I was telling you about comes into play. Okay, it turns out the 2 numbers that satisfy this are 2.5 and 2.5. 2.5 times 2.5 is 6.25. Right? But they also add to 5. Well, where did I see 2.5 on my page? This is your magic number. Right? So the way this works is you could do it this way, right? And then you could write out the fact that if I factored this, it would be x plus 2.5, x plus 2.5. That's how you would write it out in factored form, right? And then you'd have the minus 6.25, close the bracket, plus 6, right? And then because I have 2x plus 2.5s, right? You could go x plus 2.5 squared minus 6.25. So that's starting to look a little bit more familiar now, right? You can see this piece here. The point is, I don't need to do all this, right? It's just like behind the scenes, behind the curtains. If you can identify what that magic number is, you just write it right here. You skip all of this. Like this whole piece right here, we don't need. Right? And then the last part is just collect these terms here. And I have you putting the square brackets in for a different reason, just to prep us for tomorrow. So don't worry about the square bracket business for now. They're there to like prep you for the stuff we do tomorrow. Okay. So all you have to do is what's negative 6.25 plus 6. And that's your final answer. That's vertex form. Right? So once I get it into vertex form, I can read off what the vertex is. It says, okay, so I get a, therefore is it opening up or down? Up, so I get a minimum, right? So therefore, minimum of negative 0.25 when x equals negative 2.5. Right? Because the vertex is what? If I were to write the vertex out. Okay, not an easy concept. Becomes easy when you do 30 times. You just go on autopilot. It's easy, right? Like I've done this enough times now that like you just know it. It's 1, 2, 3, 4, and it's done, right? So if you do 10 of these questions, if I ask you to complete the square on the test, which I will, right? It'll just be an easy mark. It's easy 4 marks. It's 100%, like when you see kids that can't do completing the square, it's about the amount of questions that they've done. I suppose some of it's like how it gets taught too, right? Like I don't really care about bogging kids down with this. This is silliness. I don't need that. You can identify that number and you put it right there. You skip this entire line. You don't need this. Okay? You want to do the next one? And then I've got a whole bunch for you. Okay. So we'll ignore some stuff up there, and we'll just do this one as if you could just follow it, right? You don't need to worry about the logistics of how things are happening. You could just do it and write it in 3, 4, 5 steps and be done, right? So what did I say the first step was? Find Z, right? Z is always the B value divided by 2 squared. Okay. So B in this question is 8, right? Right. 8 comes from the B value in the standard form, right? 8 divided by 2 squared. So I'm going to get 4 squared, which is equal to 16. Okay. So second step, rewrite it, add Z and subtract Z, and throw the last term away. Right? So y is equal to, open the square bracket, x squared plus 8x plus 16 minus 16 plus 23. Third step, we can go y equals, find the magic number. It's the number before you square it. It's positive, so I'm just going to write it like this. X plus 4 squared minus 16 plus 23.
16 be positive?
So this negative 16 comes from here. So when I use this magic number, the magic number condenses. Maybe this is a good one to do. Okay, so
Why wouldn't it be positive? Like 4 squared with 16.
okay, so when we did this magic number thing, it was only about the first 3 terms. Okay, so if I were to do this work over here, I'll do it. This one will work better. Everybody should be able to see this one, right? I need 2 numbers to multiply to 16 and add to 8. Right? That is true. It needs to multiply to positive 16, right? But don't forget that we've got this other one floating here, right? Sorry, not that one. This one. That one's not involved in the first 3 terms, right? It's just floating there. And it's going to carry itself down until I deal with it. Right? So if I were to condense the first 3 terms, like this is me condensing in red, right? The 2 numbers turn out to be 4 times 4 satisfy both those conditions, right? So 4 and 4 multiply to 16, but then they also add to 8. Right? So if I were to, like, let's say I'll write line 2.5. Okay, step 2.5, right? Y is equal to x plus 4, x plus 4, minus 16 plus 23. Okay, so that'll be like the step in between step 2 and 3, right? And then you could say, okay, well then I've got 2 of these. Let's condense them down. You just write what's left, right? So then y is equal to, we can just finish this out now because we're at the same stage. So y is equal to negative 16 plus 23. That should be positive 7, right? Okay, and then you could say, okay, well, what's the vertex? The vertex is negative 4 and 7. So therefore, is it opening up or down? Up. So we get a minimum of 7 when x equals negative 4. Okay, I'm trying to avoid this. I don't think you guys need this. I think it complicates things and just throws too many steps. Like, you could do this in, here's your 5 steps. You're done.
On the first one, could you just cross out like the steps like aren't necessary? Like, I don't know.
You mean, okay, so I could do
Could I have like 1, 2,
too many, yeah.
5? Oh wait.
We can do, I have homework ones here. We could do one of the homework ones if you want. But basically you're not going to need, I don't need any of this, right? You can look at the 2 solutions, right? And like kind of see, okay, what's different about them, right? Like that's honestly like I don't need that, you know, you don't need any of this. This is me showing you the mechanics of what's happening, but you don't need the mechanics. You can just identify that this is the number that needs to come right here and square it. And then write the other 2 that you've got left. Okay? So why don't you try a couple on your own?